Question 16 from the heat topic. A child wanting to make a cordialized block places 200 grams, that's a mass, of cordial at 25 degrees Celsius in the freezer. If the freezer can remove energy at the rate of 25 joules per second, what time will it take for the cordial to freeze? Assume the specific latent heat and specific heat capacity of cordial are the same as water. So basically water we're dealing with here. Okay, so that's the initial temperature. Can remove heat energy at the rate of 25 joules per second. Okay, so we know that it's going to change temperature because we have to freeze it. So what we have to do is two things. First, we have to cool down from 25 degrees Celsius down to 0 degrees Celsius. Okay, so the water's got to cool down to its freezing point. But then it has to turn into solid. So at this point, all we've done is cool down the water to 0. Then we have to freeze the water. Cordial, really. Okay, so that's getting from liquid to solid. Okay, so how do we do that? Well, the first stage is cool it down. That's a change in temperature. So that's Q equals mc delta T. So it's the mass, which is 200 grams, that's 0.2 kilos, times the specific heat capacity, so that's water. Here it is, specific heat capacity of water is 4,200, times the change in temperature, went from 25 degrees down to 0. So that changed by 25 degrees. There we go. So the energy is 0.2 times 4,200 times 25. So that's 21,000 joules. So that's how much heat we had to get rid of to cool it down to 0 degrees. Now, we have the second stage of this problem. We now have to actually freeze it. So that's just going from liquid to solid. It's not changing temperature, it's just changing state. So Q equals ml. So the mass is the same, it's still 0.2 kilograms, times the latent heat for water. Now, this is going from liquid to solid, so it's fusion. Okay, not vaporization, that's liquid to gas, or gas to liquid. So here it is, latent heat of fusion, 3.34 by 10 to the 5. Okay, so 0.2 times 3.34 by 10 to the 5 is 66,800 joules. Okay, so in those two steps, so therefore the total energy removed, because remember this is cooling down, it's not the total energy added to the water, it's the total energy removed from it to cool it down. So that equals 21,000 plus 66,800, which equals 87,800 joules. Now we know our fridge can remove 25 joules per second, so 25 joules for 1 second. So we've got to we've got to remove 87,800 joules for X seconds. And also notice that you always have to match the different things you're measuring here. So because we wrote joules first, then seconds afterwards, you have to write joules first, then seconds afterwards again. You can't mix and match them. You can't have joules here and seconds here. Okay, this won't work otherwise. So Suzanne rule. So the known diagonal is 87,800 times 1 divided by 25. So 3,512 was the answer. So as X was 3,512, so therefore it's in seconds. And for those of you who know, there's 3,600 seconds in an hour, so this almost took an hour. And that's it.